Good morning, I'm Mr. Precella. I'm going to continue my discussion of finding derivatives for my Math 1325 class. I'd printed out a series of 20 problems to work out, and I think I went through the first 8 in the previous video, so I thought I'd pick up here with number 9. And just to make it easier, I've already written down these problems here on this tablet, so I won't have to be switching back and forth between the pages. Remember the last time I stated a series of derivative rules that we'll be using to find the derivative of functions. So the derivative of a number by itself is 0. The derivative of x by itself is 1. If you have a coefficient times x, the derivative is that coefficient. Now the power rule, this is the important one. If you have a variable to a power, bring down the exponent, subtract 1 to get the new power. And if you have a coefficient, it's exponent times coefficient, subtract 1 to get the new power. And then this fourth rule says to find the derivative of a sum or difference, you just differentiate the terms individually. You'll need to recall your definition of rational exponent. In particular, you need to recall that when you see a square root, that's the same thing as an exponent of 1/2, and in general, an nth root, that's the same thing as the exponent 1 over n. So with that in mind, getting started. I guess I'll leave this here. They want us to find f prime of x. We have a number times a variable to a power. Number times a variable to a power. You take the exponent 1.5 times 10, subtract 1, 1.5 minus 1 will give us the new exponent. Minus, you take the exponent, 0.5 times 6, subtract 1, to get your new exponent. And that's an awful lot of purple. I'll change colors. 1.5 times 10, that gives us a 15. 1.5 minus 1, that just leaves me a 0.5 as the exponent. Minus 0.5 times 6, that's a 3. X, 0.5 minus 1 is a negative 0.5. For my final answer. Any questions there? Okay, what about this one here? Okay. You take the 5/2 and what do you do with it? You multiply it by negative 12, so f prime of x, that's 5/2 times negative 12. What do you do to the exponent to get the new exponent? You subtract 1. 5/2 minus 1. Plus, you take 1.2 times 6, subtract 1 to get a new exponent. Plus, what's the derivative of x? The derivative of x by itself is just 1. What's the coefficient on x? It's an assumed 1. The derivative of a coefficient times x is just that coefficient. Really, I could have just stated the second half. I didn't have to state that first condition there. And cleaning this up a little bit, let's see, that's going to give me what? A negative 30 x. 5/2 minus 1, 5/2 minus 2/2 gives me 3/2 plus 1.2 times 6 is a 7.2. 1.2 minus 1 is just a 0.2. And we still have what? The plus 1, I agree. Y'all getting the hang of exponent times coefficient to get the new coefficient, subtract 1 to get the new exponent? Hopefully y'all are. We're going to be doing that a lot this semester. I doubt there'll be a day that goes by this semester from here on in that we're not doing that. F prime of x. You take 3 halves times 22. The 2 goes into 22 11 times, so that gives me a 33. Subtract 1, 3 halves minus 1, that's 3 halves minus 2 halves, that gives me a 1 half. You take the negative 1 half, no, you take the 1 half times a negative 8, that gives us a negative 4, x. Subtract 1, 1 half minus 2 halves, that gives us a negative 1 half. For my final answer, maybe I should write that bigger. I have the room. F prime of x is equal to, I'm a big writer myself, and when I have to start writing so small, I have a hard time controlling myself. I want to write big. So there's the answer. And okay, let's go on to another one. Here's one. This is a good one. We ran into a radical on the last the last video. If you have a radical, before you can differentiate it, you have to do what? You have to rewrite it as an exponent. What exponent is equivalent to a square root? I told you all that at the beginning of this video. 1 half. So there's the function. And now we're ready to find the derivative. You take the 1 half, and what do? You take the 1 half, you multiply it by 4, that gives you a 2x. Subtract 1. 1 half minus 2 halves gives you a negative 1 half. Take the 3/4, multiply it by the positive 20, that's going to give us a positive 15. Subtract 1, 3/4 minus 4/4, that gives me a negative 1/4 for my final answer. Once you realize you can rewrite that square root of x as an x to the 1 half, you just apply the power rule to each of the individual terms. Falls out pretty nicely. Here's one. We can do this one very quickly. You take negative 4 times 3, that's negative 12. Subtract 1, negative 4 minus 1 gives me a negative 5. You take the negative 1 and do what? You take the negative 1 times negative 2, that gives you a positive 2. Subtract 1 to give you an exponent of negative 2. Once you get the hang of that power rule, you can find these derivatives very quickly. Let me check the time. What time is it? Okay, we still have some time. This one here is another one that we can do pretty much in one step. You take the 2 times the 5, that's a 10. Subtract 1. 2 minus 1 gives us just an x to the first power. What about the derivative of minus 3x? What's the derivative of a number times x? The derivative of a number times x is just that number. And the derivative of negative 4x to the negative 2, you take negative 2 times negative 4, that gives us a positive 8x. What's the new exponent? Negative 2 minus 1 gives me a negative 3 for my final answer. Now getting the hang of this. Okay, here's another one. It's going to be messier. Well, it's not really going to be that messy. We're just going to have to rewrite the problem before we can apply our derivative rules. We don't have a derivative rule that tells us what to do when the variable is being divided. So, or when the variable is in the divisor. So we had one like this in the previous video, I think. What did we do? We said that that's 1/5, that's the coefficient. You pick the s to the 4th power up, you move it out of the denominator, and that becomes an s to the -4. That's a -5/4. Pick the s cubed up, move it out of the, not the derivative, you move it out of the denominator, move it out of the denominator, this becomes an s to the -3. I'm saying the wrong d word. That s to the 4th was in the denominator, move it out of the denominator, change the sign on the exponent, s cubed, move it out of the denominator, change the sign on the exponent. And that's not the derivative. Now we're ready to find the derivative. Differentiating r prime equals, you take -4 times 1/5, that's -4/5, subtract 1, -4 minus 1 gives me a -5. Now I take -3 times -5/4. Negative times negative, that's going to give me a positive 15/4. Subtract 1, what am I going to have as my new exponent here? -3 minus 1 gives me a -4. Yes. Okay. We still have some time. Let's do number 16. Look at that one. Look at number 16. Let me recopy that here because we're going to need plenty of room. Y equals 9 plus 7x minus 6 square roots of x, all divided by x. In a couple of assignments, we'll get something called the quotient rule for finding derivatives. That's where you can use that when you're dividing functions of x. But we don't have that yet. All we have basically is that power rule. So we're going to have to rewrite this as just a series of sums and differences of numbers times x to a power. And the way we're going to do that, first of all, that square root of x, we know that that's x to the 1/2. So I'm going to split up. Take the 9, put it over x, plus take the 7x, put it over x, minus take the 6, x to the 1/2, put it over x. I put each term in the numerator over x. And now I'm going to rewrite that. I'm going to simplify each term until it's a term that I can find the derivative of. So 9 over x. I can rewrite that using a negative exponent. I have a 9. That's an assumed power. I don't see an exponent on this x here, so what's the assumed power? 1. Pick it up, move it out of the denominator. That becomes an x to the -1/2. What's that second term going to reduce to? It couldn't get much nicer. That second term's going to cancel the x's. That just becomes a +7. 6x to the 1/2 divided by x to the first power. We have a -6x. What exponent? Here's something we haven't used before. Well, you've used it plenty of times in other math classes, but recall the the quotient rule. B to the m divided by b to the n. If you have repeated bases being divided, what do you do to the exponents? You subtract them. That's our cancellation property that we use. Now recall that. In which case, x to the 1/2 divided by x to the first, you subtract 1/2 minus 1, 1/2 minus 2/2. Our new exponent then is -1/2. And this stuff is not the derivative. We haven't started finding the derivative yet. At this point, all we've done is use algebra to simplify the function so that we can find the derivative. As I told you, people tell me that it's this stuff here, the messy algebra, that gives them problems. It's not the calculus portion. We have not started the calculus portion of this problem. Now we're going to start the calculus portion. So y prime is equal to negative 1 times 9 is a negative 9. Subtract 1. Negative 1 minus 1 gives us a negative 2. Plus, what about the derivative of 7? That's just a 0. I'll go ahead and show it this time. Then you take the negative 1/2 times a negative 6. That gives us a positive 3x. What do you do to get the new exponent? Negative 1/2 minus 2/2. Negative 1/2 minus 1, that's negative 3/2. So that gives us y prime equals a negative 9x to the negative 2 plus 3x to the negative 3/2. Suppose I wanted to rewrite those with positive exponents. Suppose I wanted to rewrite those with positive exponents. My math lab will accept this. But suppose I wanted to write them with positive exponents. You'd have a negative 9. Take that x to the negative 2, move it down, becomes an x to the positive 2. I'm undoing this step from here to that. I'm going back to positive exponents. Plus, I have a 3. It's going to stay on top. You take the x to the negative 3/2, move it down, becomes x to the positive 3/2. My math lab would take either one of those answers. And as I'm looking at these, none of these seem particularly rigorous. Here's a good one. We've done this one and this one. Here it's just another matter of multiplying exponent times coefficient. Same thing for 17 and 18, so I won't bother with those. Number 19, this is a good one. Let me write that. Y equals negative 10 all over the 4th root of x. Negative 10 divided by the 4th root of x. What did I say you have to do? If you have a radical, you have to rewrite it how? You have to write it using an exponent. So x to the 1/4. And I would then pick up that x to the 1/4, move it up to the numerator to give us a negative 10 x to the negative 1/4. And once again, I haven't found the derivative yet. I'm just having to rewrite this so that I can apply my derivative rules. Negative 10 divided by the 4th root of x. The 4th root of x is the same thing as x to the 1/4. I then pick up the x to the 1/4, move it out of the denominator, changing the sign on the exponent. And once you do that, the derivative falls out very quickly. Y prime is what? Negative 1/4 times negative 10. That'll give me a positive 10/4. And that's what? A positive 5/2. Subtract 1. Negative 1/4 minus 1. That's negative 1/4 minus 4/4. That gives me a negative 5/4. And I just leave it like that. And let's see. I have one more I want to do. I think I have time to get it done. Someone's shaking their head. No, I don't have time to do it. But yeah, I do. 5x to the negative 1/3. Look at the way they've written it. X to the, what is that, 5/3? Notice the notation. They say find the derivative, and they're writing it using that capital D sub x notation. Here's the function, 5x to the negative 1/3 plus 6 over x to the 5/3. They want us to differentiate it. I've written it there. I think I like that notation, y equals and then y prime equals, but okay. So I know how to differentiate the 5x to the negative 1/3. I won't have a problem with that. I'll do that in a moment. But this thing here, that's a 6x. What am I going to have to do? I have to pick the x to the 5/3 up, move it out to beside it, change the 5/3 to what? Negative 5/3. Okay. And now we're ready to find our derivative. We're ready to apply the derivative rules. Take negative 1/3 times 5. That's a negative 5/3. Subtract 1. You tell me, what's this exponent going to be? Negative 1/3 minus 1. Negative 1/3 minus 3/3. And negative 4/3. Then you take the negative 5/3 times 6. That's a negative 10. Subtract 1. You tell me what that new exponent's going to be. Negative 5/3 minus 1. Negative 8/3. I agree. Negative 5/3 minus 3/3 gives me a negative 8/3. And I think we're about out of time now, so I hope with these two videos I've done that I've given you enough examples to help you see how you apply those derivative rules. And in the next homework module, we're going to be looking at applications of the derivative. So yes, you have that to look forward to. We'll be doing word problems in the next homework module. But until then, bye-bye. Work on your homework. Oh, and get the hang of these derivative rules because they are not going away. We will use them every day from here till the end of the semester. Bye-bye.